got people from time to time that ask us about break-in, burn-in on headphones. Cables are the same thing, break-in cables. People tend to be familiar with burn-in on screens like flat screens, OLED, LCDs, where you have the same image or whatever on a screen and it becomes permanent as years go by, right? Like when you go to, like we talked about airports, you go and you see if they ever change the screen or the layout, you still see the old grid pattern from what they had on there.
I saw that a few times.
Yeah.
I saw it was like a TV that was broken at one of those like airport terminal things, and the TV was off, but you still saw text on it, right? It wasn't lit up, it wasn't illuminated, but you could see the distortion in the panel.
That has gotten better, though, in newer models.
Yeah.
They used to burn in way easier.
Yeah, they've come up with novel ways to save the pixels from...
To mitigate it.
Yeah, right, which we could talk a little bit about pixels if you want to cover a little bit about what the
Well,
cause of that is.
For the most part, it's a software approach. Very different end result for OLED burn-in and a mechanical burn-in for a headphone. But people kind of associate them as the same thing. For OLED TVs, it's really just the pixels being used. So it's not so much that you're displaying a static image, it's just the fact that this pixel is being used and the one next to it isn't. When it's being used, it wears a little bit, right? And so now you display a solid, like a flat image, and all the pixels are supposed to light up evenly, but one got used and the other one didn't, so they're wore a little differently. They have different levels of use to them, and you could see different brightness differences. It doesn't really work that way with headphones.
Yeah,
it doesn't.
You can't unevenly break them in.
Well, they don't. First of all, headphones don't have pixels.
Well, yeah.
Some may say they have pixie dust, but that's all different.
We don't have like a small segment that you can only use at a time. Pretty much anything you play through it uses the whole thing, and it causes some degree of break-in, you could say. And some people say that that's not real in drivers, that break-in doesn't exist. That's very easy to disprove. You can measure it. Now, it depends on the driver, how much they exhibit. Different drivers exhibit from practically no to very considerable differences from break-in. But on our headphones, you can indeed measure the break-in. Yeah. It's not that hard to do.
Assuming you have the means to measure it.
Sure.
And I mean, even like if you think about it, like a tweeter, people can't even picture like a tweeter or a speaker breaking in. I imagine over time they do too. I mean, what people don't understand is what they're not really understanding is that it's not just a speaker's not just that cone you see or that surface you see. Yeah, you've got adhesives you're dealing with. It's a mechanical system. It moves, right? So the material can stretch, give in different directions depending on how it was extruded or whatever. There's all kinds of reasons why a material may vary over time given mechanical motion. And, so to say that something doesn't break in is really kind of not true because everything breaks in, if you ask me. I mean, in terms of something physically made, when you're changing, whether it's a mechanical motion, temperature variations, whatever, when you're flexing the material in some way, you're changing it slightly. You're changing its dimensions or the way it's fastened. You're changing the way it's held, and unless you weld steel to steel, right? Where it's all one piece, right? I could see where you could say, okay, that piece doesn't break in.
Well, even then you get fatigue.
But everything around it does. Well, that's true. You'll get fatigue through the welds.
Yeah, tanks don't last forever.
Right.
From pressurizing and depressurizing, they need to be replaced. They need to be inspected.
Like airplanes.
The welded material, what you're using for the welding is probably different material than the actual metal itself.
Well, maybe not.
Yeah. But it's probably, it could be similar but not exact.
But it's a common issue in industry. People are probably unaware, but any pressure vessel needs to be inspected for cracks and damage, fatigue, and intermittently replaced because they will fail, and that causes deaths. If a pressure vessel goes off, if it's a big one, depends on what it's holding.
Yeah, a big one like an airplane, as I said.
So even a steel tank.
Even a steel tank wears.
Yeah. Or fatigues or changes or
and
breaks
in,
so to speak. Yeah.
Well, in the U.S., what we do with our planes is after so many pressurizations, we give them to other countries that have.
Do they take them?
Yeah. Or you use them as a cargo plane and you don't pressurize them anymore.
Right.
Yeah. Because at some point the shell is no longer rated to handle continual repressurizations and the fatigue associated.
Yeah, and you got, not only that, I mean, you think of other materials, if there's any friction point involved where you got materials rubbing, then obviously there's a wear point there. which you don't really see in drivers or speaker designs, but I'm talking about other things. But bottom line is that, a break-in, this affects the frequency response, or subtly even how the ear perceives the overall picture that this speaker driver or speaker system is giving you. Your brain is reproducing an actual image, and it's doing it from the information it's getting, and it's a lot of subtle information that sets that up. So, the break-in affects subtle information. That's what it does.
I think the easiest example is subwoofers. It's massively obvious in subs.
Yeah.
Like you get them brand new,
They're stiff as hell.
and it's like, this thing's not making any bass. It sucks,
Yeah.
But eventually, you'll hear it,
and if you ever push one of those drivers in with your hand,
yeah.
they're stiff as hell. You could practically, on a subwoofer driver, you could probably stand on it. Car subs would be the same
lot of
thing.
them, yeah.
The suspension, and see, people need to understand it. It's designed like that. Like, they know the materials they're making, the thickness of the surrounds and the spiders, right? The manufacturer knows how it's going to break in. They already know. They've already done that testing. So they know they need to start stiff to get to their final, whatever the suspension they want to be is. You know what I mean? They don't expect it to stay the same from new.
They know it won't
happen. Yeah. So they've already got that planned out. And it's the same with us. When we design something, we understand, because we've done it so many times. We've made these parts before, and we have parts here that were made similarly that years ago to compare to. We know where these things are going to go.
Yeah.
So we can
Of course,
compensate.
planar magnetic drivers typically don't break in or wear to the same level of like a subwoofer.
Yeah, no.
Nowhere near as extreme,
Thank
but
God.
that's not to say it doesn't happen. Obviously, at some point, you need to retain the diaphragm. It needs to be tensioned and fastened somehow mechanically, and that part is typically stationary. But the diaphragm does move, not much, but it's not zero. So there's that interface between the part that has motion and the part that does not, and that flexes, distorts, wears, and to some extent, it depends on how you retain it, but that very much changes how easy the diaphragm can move over time.
So what we do basically is we've already baked that into the design process, the manufacturing process, the assembly process, so that we know that once this thing has hundreds of hours on it or more, it basically will find a certain final resting position where we want it to be.
Everything's a spring.
Yeah. A spring.
Yeah.
Pretty much.
Yeah.
But I guess that brings up another question. What should you play to break in your headphone?
Yeah.
Or is there different things that break it in differently? Is there a difference in the end result if you play classical versus rock music when you're breaking in your
Or
headphones?
would it sound different if I use different music to break it in?
Yeah. This is a complicated one, but overall the answer is kind of yes and no at the same time. The things you play will, of course, affect how much the driver moves, how fast it moves, the rate at which, the speed, the travel, the extent. And to some degree, also the heating of the diaphragm, depending on the design. And these things will have an impact on the break-in rate, but not so much the end result. The end result's the same pretty much either way. It just depends on how quickly you get there. And I guess there is a trade-off, because some people think, well, I'll just hammer it. I'll just crank my volume. I'll walk away. I'll
Brute
break this
force.
in 15 minutes.
Put some heavy
Yeah.
bass on there for a couple
It
days.
doesn't really work. I tried this.
Yeah.
You could break some things in fast, but there's other things, especially adhesives, that you can't really break in 5 minutes.
Well, that's the thing. Like, people don't realize that it's not only necessarily the mechanical motion of it, but the adhesive itself probably is still slightly changing or setting up over time. Particularly on a newer headphone that was just made in the last few weeks, month, or whatever. The adhesive is set, and they give you specs for that 72 hours or whatever. But the reality of it is, what happens after 72 hours, nobody really knows, right? So these are variables that occur with anything that's assembled over time, and it's a variable. And so, we don't have we just know from our assemblies, we'll tell people, well, 100, 150 hours is usually, for most people, once you reach that amount of playtime on a headphone, you're probably not going to notice huge differences beyond that. It's a good number.
I mean, just sitting there doing nothing, they slightly change
Right.
just because of that.
Exactly.
So
Yeah.
we have rest periods specifically because they do change.
Yeah. Yeah, you mean in the assembly process? Yeah, where we have to let materials settle till we do the next step, because we know that if we don't do that, then as they age, they won't wind up in that ultimate rest state we want them to be in. So, yeah, it's a tricky procedure. But, yeah, we got that
Yeah, I think
done.
we talked about that before. But it's kind of one of those questions of if you match something, when was it matched? How was it matched? I think we talked about this in our QC video. But the hope is you always try to design something that wears in to perfection. Doesn't necessarily need to start at perfection, but you want to have a long span of time where it wears in to be perfect, or as close to perfect as you can get it. The difficulty thing is being able to match drivers to know that they're going to arrive at the right state without having them in that state initially.
Yeah, well, that's not hard, because if the assembly process is consistent and materials are consistently the same materials, then you pretty much know that the one you made, after a month of making it, 3 years later, a month after making it, it's still going to be the same. You know what I mean? That month period, at that month period, or 2 months later, or 3 months out from making it, you still know where it's going to be relative to brand new.
I guess the end result is what you play does have an impact on the break-in, but it really only varies the time required. And as a general rule, it doesn't matter that much. Moderate listening level, most music is fine. If you don't listen to stuff with heavy bass, then it doesn't really matter that much if you break it in with heavy bass.
I don't think we've narrowed it down. Like, we've never really tried. Like,
Yeah, not really.
We usually do. I always recommend use some sort of dynamic music, and it could have heavy bass, but as long as it's got dynamics where something's hitting,
Yeah.
On a regular basis, a beat to it, I think you're in pretty good shape.
Yeah, it doesn't really matter.
Yeah.
But something with a little bit of travel is good, a little bit of bass,
Yeah.
it's fine.
Yeah. I mean, if you're playing opera or something and there's like one person singing, it's almost monotone in nature. It's probably not as good as having something
probably
that's got
take a
more
long
things
time.
going on. Yeah.
Right.
Yeah, it's pretty much a duration thing, is
Yeah.
how hard you beat on them.
Yeah, to a point. But then, you could go overboard, so don't think that you should beat out. The reality of it is there's no speeding up the process. It's all going to, in the end, it's all going to level out. It's just going to take weeks or months or whatever to really get to that resting point. It's kind of like that old leather shoe that you love to wear, that when you first put it on, it was stiff as hell, And now you never want to get a new pair of shoes, because everything you put on new feels stiff as hell, and this old shoe's great.
Yeah, start that process over again.
Yeah, right. So, I mean, but it's not a long process, but by the same token, it's something that you should expect. You should never take a brand new Planar headphone or any speaker out the box and expect that's its final sound. It doesn't work. Brand new. It's not no speaker I know of, that's its final sound. Doesn't happen like that. It takes time and play time. It's just the way it's.
You would have
it's always
to
been.
pre-break it in.
Well,
from the
yeah,
factory.
that is how you would do it, yeah.
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 And
But
that,
it takes long enough on most planers that's not feasible to have it perfect out of the box, to have it fully broken in. You'd expect 100, maybe 200-300 hours, depending on volume and stuff. But yeah, you really can't just crank the volume and expect it to happen in 15 minutes.
Yeah, I
That's
think you've
not
gone
a
on
recommended approach.
you went out like a few hundred hours with it, and you said pretty much at that point it's done.
Yeah.
Anything
over 150, you can't tell.
Yeah, it starts to get to a point where the variations are not. You're not going to notice it from listening session to listening
No.
session. It's not going to be something.
Most of it happens quick. 5 hours, 10, 20 hours. That's where a lot of it happens, then kind of fades away. But it depends on your volume, depends on your music.
Yeah, it's a
listening to.
slower process as time goes on.
Yeah.
To change till it settles in. So that's breaking on a headphone, speakers, steel, ships, airplanes. I don't know what
sort
didn't we
of.
cover.
Silicon.
Pressure vessels.
Yeah.
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 How about batteries? Do batteries break in on,
Yes.
on
Yeah.
the new electric cars?
Everyone tells you not to measure capacity
Yeah.
on, like if you're buying an RC pack,
Yeah.
everyone tells you not to measure capacity without a cycle on it.
Yeah. At least
Yeah.
one cycle.
Usually the capacity grows. You can measure this. You put 1, 2, 3, 4, 5 cycles on a battery and you measure the capacity. Usually it'll go up a little bit before it starts going down. Depends on the chemistry, the design. and stuff
Everyone
like that.
figured that out on like a Tesla car or something like that. How many cycles you go through or not? Really?
Well, I mean, people don't really measure
driving,
it precisely.
driving varies. Yeah,
You know, it's
not
complicated.
yeah,
you need
right.
to have controlled temperature and conditions
yeah,
and all
right.
that.
Yeah, there's no way to tell.
Mm.
Yeah. Just know that it'll happen. It's kind of like with the headphones. Just know that it'll happen and just let it rip for a few hundred hours. And we're good. Thanks everybody for watching. Take care of yourselves. Have a good one.